Dear students, welcome to my classroom. Today we are going to start a new chapter which is very interesting in 10th class syllabus, and the chapter is tangents and secants to a circle. Students, I think all of you learned about circle in previous standards. Let us go through some points which you learned in that classes. Can you say the definition of a circle? Yes, the definition of a circle is the set of all points which are at a fixed distance from a fixed point is called a circle. The set of all points which are at a constant distance from a fixed point is the circle. Here we are looking a point here, and now the set of all points from these points like this with a fixed distance is the circle. Okay, so in other terms, we can define the circle as the path of a point which moves such that its distance from a fixed point is always constant. So here the fixed point is said to be center of the circle, and the fixed distance is said to be radius of the circle. Okay, students. And also, if A and B are any 2 points on the circle, then the line segment joining these 2 points is called a chord of a circle. Here, AB is the chord of a circle. Now, how many chords can we draw to a circle? So, here we are drawing many chords to a circle. So, in this way, we can draw infinitely many chords to a circle. And among these chords, the chord passing through the center is called the diameter of the circle. Here, PQ is the chord passing through the center, so that here PQ is called the diameter of the circle, and the length of the diameter is twice the length of the radius. Okay, here PQ is twice the radius of this circle. Also, now what are the relative positions of a line and a circle? So, how many positions are there with respect to a line and a circle? So, here we have a circle and a line. Here, the line PQ intersecting the circle in two distinct points, A and B. Now, the line PQ is called the secant of a secant to the circle. Okay, so the secant intersect the line into distinct points, and if the line PQ touches the circle at a point, then the line PQ is called tangent of the circle. Here, the line PQ touching the circle at the point A. So, this common point, that is the common point to both circle and the line, is called the point of contact. Point of contact of the circle and tangent. Okay, here A is the point of contact. So this is the second position. The first one is secant and the second one is tangent, and the third position is the line PQ does not intersect and does not touch the circle. So that is, the line is away from the circle. These are the three relative positions of a line and circle. And let us see when a secant becomes a tangent to the circle. So here PQ intersecting the circle in two distinct points. Now let us see how this secant becomes a tangent. If the two intersection points coincides, then the secant becomes a tangent. Okay, students. Now, the important point is the tangent at any point of a circle is perpendicular to the radius through the point of contact. This is very, very important point we have to remember throughout this chapter. Okay, that is, here we have a circle with center O, and PQ is the tangent which touches the circle at A. That is, A is the point of contact here. Now, this line joining O and A, that is the radius, and this radius is perpendicular to the tangent. Otherwise, we can say that tangent is the perpendicular to the radius. Okay, so at any point, if we draw the tangent to the circle, then the tangent is perpendicular to the radius at that point of contact. Okay, and its converse is also true. That is, if a line in the plane of a circle is perpendicular to the radius at its end point on the circle, then the line is tangent to the circle. That is, if OA is the radius and the peak line PQ is a tangent at the end point of this radius, that is at A, then the radius at A is perpendicular to the tangent. Okay, then PQ is the tangent. And now let us see how to construct a tangent to a circle. So first take a circle with center O like this. Here I am locating the point O and draw a circle using protractor and take a point P on the circle and then join O and P. And now using set square, draw a line perpendicular to OP through P. Then we get the tangent AB at P to the circle. Okay, students. In this way, we can draw a tangent to a circle. Now, let us know how to find the length of the tangent. Here we have a circle with center O and P is a point outside the circle. And now the line drawn from P touching the circle at A, that is PA is the tangent to the circle, and then OA is the radius and OP is the align segment. Now we can say that PA is perpendicular to OA. As we learned in this class, the radius at the point of contact is perpendicular to the tangent. So that here we have PA perpendicular to OA. So then Pythagoras theorem, in this triangle OAP, by Pythagoras theorem, we have the square on the hypotenuse, that is the square of OP square, is the sum of the squares of OA and OP. That is, OP square is OA square plus PA square. Here PA is the length called the length of the tangent drawn from P to the circle. So now we have to determine the value of PA. So from this we can write PA square is equal to OP square minus OA square. So that PA is equal to under root OP square minus OA square. So in this way, we can find the length of the tangent drawn from an external point to the circle. Okay, students. So let us start exercise 9.1. And we start with fill in the blanks. The first one is a tangent to a circle intersects it in dash points. So students, we know that a tangent meets the circle at only one point, isn't it? So the answer is 1. And second one is a line intersecting a circle in 2 points is called a, what is that? So the answer is secant of the circle. That is, a line intersecting a circle in 2 points is called a secant of the circle. Okay. A circle can have dash parallel tangents at the most. It is asking how many parallel tangents can we draw to a circle. So here the answer is 2, because we can see like this. Here we have a circle and these two are parallel, called parallel tangents. So at any time we can draw only 2 parallel tangents at most, like this. Okay, students. So the answer is 2. So next one is the common point of a tangent to a circle and the circle is called dash. So we know that the common point of a tangent and the circle is called the point of contact. Okay. And the next one is we can draw dash tangents to a circle. That is how many tangents we can draw to a circle. So there are infinite tangents that can be drawn to a circle like this. So what's this? How many tangents we are drawing? So in this way, we can draw infinitely many tangents to a circle. Okay. So let us see the second one. A tangent PQ at a point P of a circle of radius 5 cm meets a line through the center O at a point Q, so that OQ is equal to 13 centimeters. Find length of PQ. That's the question. So here we have the circle with center O, and PQ is the tangent where P is the point of contact, and the radius of the circle is given that OP is 5 centimeters, and the distance between O and Q is 13 centimeters, and we have to find the length PQ. That is the length of tangent drawn from Q to the circle where it meets the circle at P. Okay, so here the radius of circle is OP is 5 centimeters, and given OQ is equal to 13 centimeters. And we know that here at P we have right angle, because the radius is perpendicular to the tangent at the point of contact. So that we have OP perpendicular to PQ. So a triangle OPQ is a right angle triangle. And by Pythagoras theorem, we have OQ square is equal to OP square plus PQ square. So by substituting the values of OP and OQ in this equation, we get 13 square is equal to 5 square plus PQ square. From this, we can write 169 is equal to 5 square is 25 plus PQ square, and PQ square is equal to 169 minus 25, which is equal to 144. So that PQ is under root 144, which is equal to 12. So that the distance between P and Q is 12 centimeters. So the length of PQ is 12 centimeters. That is the answer. Okay, let us see the next one. Draw a circle and two lines parallel to given line drawn outside the circle such that one is a tangent and the other a secant to the circle. So here we have the circle and this is the line drawn outside the circle, and now this one is the tangent which is parallel to given line, and this one is the secant which is parallel to given line. So these are the tangents and secants. Okay, in this way you can draw a tangent and secant to a circle. Next, the fourth one. Calculate the length of tangent from a point 15 centimeter away from the center of a circle of radius 9 centimeter. So take a circle with center O and let P be any point which is at a distance of 15 centimeter from O, like this. Here the distance between O and P is 15 centimeter, and this is the tangent drawn through P where it meets the circle at Q. Now OQ is the radius of the circle, and it's given that the radius of the circle is 9 centimeter, and we know that PQ is perpendicular to OQ because the tangent is perpendicular to the radius where it meets the circle. Now we have triangle OQ is perpendicular to PQ. Okay, here we have OQ perpendicular to PQ. So the triangle OQP is a right angle triangle. So by Pythagoras theorem, we can write that OP square is equal to OQ square plus PQ square. That is the square on the hypotenuse is equal to square on the remaining two sides. Sum of the squares of remaining two sides. So now substitute the values of OP and OQ. So from this we get PQ is equal to root 144, which is equal to 12. So that the length of the tangent drawn from P is 12 centimeters. Okay, students. Now let us see the fifth one. Prove that the tangents to a circle at the endpoints of a diameter are parallel. So let O be the center of the circle, like this, and AB be the diameter of the circle. Here it is asking that the tangents to the circle at the endpoints of a diameter, that is tangents at A and B, are parallel to each other. Okay, so take PQ is the tangent drawn at A, like this, and RS be the tangent drawn at B, like this, and we have angle OAQ is equal to 90 degrees because we know that tangent is perpendicular to the radius drawn at the point of contact. So angle OAQ is 90 degrees, as well as angle OBS is also 90 degrees, like this. Now we have to prove that these PQ and RS are parallel to each other. So now we have angle OAQ, sum of the angles OAQ and OBS is equal to 90 degrees plus 90 degrees, which is equal to 180 degrees. And as we know that if sum of the consecutive interior angles is 90 degrees, then the two lines are parallel to each other. So that PQ is parallel to RS. That is, the tangents to a circle at the endpoints of a diameter are parallel to each other. Okay, students, that's all for today. And in next class, we are going to some more new points about tangents of a circle. Until then, see you. Bye.